Hi again, everyone. Today we'll go through a couple questions from the flight planning subject of the ATPL theory. All the questions that you'll see have been seen in the actual exams in the last 30 days across all EASA authorities. I hope this will help you and we'll dive a little bit deeper into the topics and the answers instead of just giving one simple explanation. So without any further ado, let's jump into the first question. Refer to this Jepson GSPRM training manual, chart 16-2. What is the minimum descent height for the NDB approach on runway 18 Charlie? So if we open the chart, remember that every approach chart will have this briefing strip right here at the top. This will give you the information such as the frequency of the locator, in this case, which is 395, final approach course, minimum altitudes for the final approach fix, and if or a point if this precision approach, and your minimums. So here you can see that the decision altitude is 690 and the MDA in the brackets, MDH is 702. In this case, DA and MDA are exactly the same. So sometimes on the plates, you will be able to see that DA and MDA are exactly the same because you will use the DA if your aircraft is equipped with appropriate FMS that can calculate the vertical profile. However, the H is in the brackets. This is why the DA and MDA are the same, and the height is in the brackets. This is slightly tricky because here, as you can see on the right side, the runway elevation is actually 12 feet below the sea level. This is why the height will be slightly higher. And this is a little bit confusing, which can be like so sometimes. And yes, so 602 will be the correct answer right here. Now moving on to the answer number 2. In Dubrovnik, charts 19-1 and 19-2 from Jepsen 2017. What is the elevation of the highest obstacle on the chart? So actually, I have prepared 2 questions asking about the highest obstacles on the chart, as these are very easy only if you know what to look for. So if you have a view like this one right here, so looking at the area or a VFR chart or any other chart than an approach chart, then the highest altitude depicted on the chart will be in a white box like this one, 5,017 feet. However, if you see an approach chart, then the highest altitude on the approach chart will be depicted by a fat and quite bold black arrow pointing into the highest altitude. So in this case, we have 5,017, and of course, these are above mean sea level, so these are altitudes. And we'll see the next one when the next question comes. So the ICAO document 8168 states that specific altitudes are established for each aerodrome that provide at least 300 meters, 1,000 feet obstacle clearance within 25 nautical miles of the navigation aid. So which of the following abbreviations is used for such altitudes? And this, of course, is MSA, minimum sector altitude. And the minimum sector altitude is almost the same as the TAA or the terminal arrival altitude, which will be also 25 nautical miles radius, but from a specific point, such as intermediate or initial approach fix. This gives you obstacle clearance of 1,000 feet or 2,000 feet in mountainous areas. This obstacle clearance becomes slower and slower the closer you are to the obstacles. And this can also be given in areas or parts of a circle, so there can be 2 MSAs in the same airport. Unfortunately, for the exams, you'll need to know all of these, so minimum crossing altitude, minimum en route altitude, or minimum obstacle clearance altitude. And all of these will give you something slightly different. So MEA, of course, gives you radio reception across the track. So these are slightly higher and also ensures obstacle clearance. And the minimum obstacle clearance altitude will give you 1,000 in non-mountainous and 2,000 in mountainous areas of obstacle clearance across your track. However, you need to know all of these for the exams, so I highly encourage you to study all of the different altitudes. So which of the correct statement with the reference to an which is the correct statement with the reference to an RNAV SID? So standard instrument departure, which is RNAV. So let's go through all the possible answers. The aircraft must be fitted with an out-of-flight system to follow the RNAV SID. That is not true. You can fly it fully manually. The RNAV SIDs are unavailable if ground-based radio navigation aid is used. Um, not specifically, because RNAV SIDs can be flown using GPS, for example. In that case, it will be very similar to an RNP, require navigation performance. However, the difference between RNAV and RNP is that RNP requires monitoring and alerting, and RNAV does not. However, it can also be flown using only GPS, so it doesn't require ground-based radio navigates. Also, you can fly it using INS. The RNAV SID can be flown without ground-based radio navigates. Yes, if you have an RNAV GPS SID and your aircraft is equipped and appropriately licensed, and you are as well, then of course, why not? And the departure procedure is limited by transition altitude. It is absolutely not. This question doesn't answer. Sorry, doesn't really make much sense. And there it is. Question number 5. What is the elevation of the highest obstacle, natural or man-made, depicted on the chart? So this is the question I was referring to slightly earlier. So this is the second option. And right here you can see the approach chart. And on this approach chart, you can see this big and bold black arrow pointing into 4,252 feet. And this is our highest altitude. So we don't need to look any further. It's right there. This question can take literally 2 seconds if you know where to look. And as a bonus, you can see this is what we discussed slightly earlier, about the MSA. As you can see here, it's divided with each sector of the MSA being slightly at a different altitude. So this is possible, and this will always be depicted on the approach chart. So 4,252 feet. Now question number 6. The section of routing is via Yankee 96 to Norbo to Tala. From Norbo to Tala. Find the true course to Tango Lima Alpha. The true course to Tango Lima Alpha via Yankee. So there it is. You have Yankee 96 here, the route. And then you have Norbo on the left and Tala on the right. So here you can see we have the magnetic track 099 across the route. We are using the VOR Tango Lima Alpha, and of course the routes that are using the radials from the VOR are always magnetic. So we have a 099 which is magnetic. In order to get a true, we need to change magnetic into true. Here at the top, you can also see in green this diagonal line, dashed line, is our magnetic deviation. So we have free west. And of course, when we're changing from magnetic, we always add the deviation. However, we add the easterly deviation and we subtract the westerly to get the true from a magnetic. So this will be 99 minus 3 because it's westerly, and this will give us 96. I always use the mnemonic Cadbury Dairy Milk, very tasty. So milk, very tasty, magnetic, variation equals true. We subtract west and we add the eastern. And now for question number 7. So what does the DS050 indicate on this SID? So this DS050 is right here at the bottom. So the question is essentially asking us if we know what these kind of waypoints are indicating. And there are 2 that we need to remember. Flyby and fly over points. The way I remember it is that fly over points have this very big circle around the star, and the flyby have nothing, it's just the star. So the big circle is like an O, meaning fly over. That's how I always remembered it. So in this case, this will be a flyover point. And going into the last question, which statement is correct for an aircraft if its VNAV capabilities are down and only LNAV can be used during an approach? This can happen, and sometimes if you brief it before the approach, you can actually continue, but you have to maintain the LNAV minima, which always will be higher, as now the level of guidance is slightly degraded. And of course, LNAV is only a lateral to the approach. It only gives you lateral left and right guidance. It does not give you vertical guidance. So in this case, it will follow a 2D non-precision approach without vertical guidance. So we need to calculate it in your head, just as you do for the CDFA approach, meaning you'll need to calculate the appropriate vertical speed for your ground speed to go down to appropriate minima. So this will be everything for today. Thank you so much for watching. I wish you all the best for the upcoming exams, and I hope to see you in the next video. Bye-bye.